No, I just,
Yeah.
I don't
Okay.
want to rush you guys.
Okay, so basically, okay, what on the assignment threw anybody, since we were able kind of to do it? Stephanie, look through it and which ones make your head spin?
On which part, the lesson,
10.
individual preparation part?
Yeah, well, either part 1 or part 2. What do you see that what is confusing to you? Because section 1 just goes over all the rules and gives you the information, whereas section 2 actually just works all those problems.
Yeah, it's the, hold on, let me tell you.
Okay. When you think about getting some,
Just like the basic, like the formula, the new formula they're giving us for how to find the parameter of the statistic, because I'm like, well, wait a minute, because that was one of the test questions was statistic or a population, and I'm like, well, if you're finding a, I'm trying to remember, a statistic of a population, then, or anyways, I just kind of was messed up about that part, because it's kind of, I'm thinking the other way, but now I'm wondering if I got that question wrong on the test, and then.
Well, I think in this lesson it actually defined them both very clearly, whereas before I felt like it just kind of didn't. But a parameter is the information from the population. So it's the set standard.
It's the whole thing, right?
So the numbers you're getting from the population, that's the parameter. The statistic is what you find when you use a sample
Of the population.
of the population, because then you're using parts of the population numbers, but you're finding based on the sample what those answers are, and those answers are statistics.
Okay.
It's a variable. Statistics are variable, whereas a parameter is something that you're just given. It's the information, it's understood and accepted as a whole.
Yeah, and it said in the reading, it said a statistic is any number computed based on data.
Mm-hmm. So you have to do something to the material for it to be a statistic. It talked about one of the examples in the PowerPoint. He says you're flipping a coin, and you're saying, what are the odds it's going to be heads? It's going to be 50%. It's a 50% chance it'll be heads. Then you flip it in the air, and after you catch it, you know, and slap it on your arm, it is no longer a parameter. It is now a statistic because you've already done something. So even though there's still a 50% chance it could be either one, there's no chance left in it because it already is whatever it is. It either is or it isn't.
Okay.
You know what I'm saying? It's not a chance that it could be or a chance that it can't. It either is it or it is not. That's what a statistic, that's where you get the statistic from. Is it something
so once you do one measurement of that sample, it is now a statistic, and then you do the rest of your sampling to get
the rest
more
of, yeah, anything that you do something to becomes a statistic. Anything that you're given the information on, that's the parameter.
Okay.
Or it's the set boundaries that you're using to find your statistics. That's what a parameter is.
Okay.
Okay.
So I have a question. So in this new formula that we're doing, confidence interval, the standard deviation and the X bar are interchangeable numbers?
No.
They did make that kind of confusing.
Yeah. The X bar is your value. It's the means that you're using. The standard deviation, that was just telling you. Where did I make that? Because I remember that was a little confusing.
No, I mean the mean and the X bar are interchangeable.
Yes, that's interchangeable.
Okay.
I'm like, no, the standard deviation is totally different. But yeah,
I should have looked at it before I asked the question.
No worries, totally fine. Yeah.
Okay.
Yeah, and then now, and actually here is where the X bar actually, the sample mean, instead of being a sample mean, it's now called the point estimate. So it's the same thing, but it has new terminology, so when you're plugging it into the formula, it has a new meaning. Same thing with like the z-score is now called the critical value. Because we're doing something a little bit different with it. So.
Okay. So the formula 2 times the standard deviation over the square root of the population, what is that little part of that formula? What is that little part?
Which little part? I'm sorry, say that again.
It's 2 times the Standard deviation over the square root of the population.
Where is that?
Oh.
That's like in the lesson under part 4. It's like under confidence intervals for the population mean when sigma is known.
So, okay, it's say it again. It's what?
It's like on the textbook part of it.
Mm-hmm.
It's like at the very beginning of part 4 where it says putting it all together.
I have to pull that up because I didn't see. I don't know if I just didn't see it or what, but I may have breezed through that part, not worrying about it.
So is that's your margin of error?
You're asking about what the 2 is, or what is your exact question again? Sorry.
The two over the standard deviation, or no, 2 times the standard deviation over the square root of the population.
That does give you the margin of error.
Okay.
Yeah, I didn't write that particular formula down. The 2 is.
I do know that the first half of that problem right above it on 4, you remember in the video he said you minus the first half, and then you add the second half.
Mm-hmm. Oh, the 2 is because it's 2 standard deviations.
Yeah, I just wondered what that little part of the formula, because they give you that little part of the formula, and then they give you the probability statement.
Yeah. Well, for this problem that for what they're doing right here in this one, they're doing 2 standard deviations.
Mm-hmm.
That was kind of, sorry.
It's saying 95% of the time the mean will be within 2 standard deviations. So that's the 95 percentile. That's what they said. 95% of the time, your population mean will be, or your sample mean will be within 2 deviations. That's why it's 2 times the sigma divided by, or 2 times the standard deviation divided by the square root of the sample. That's why the 2 is there.
Okay.
That's because of this particular way that they're explaining it. Now, just to do it generally to find 1 standard deviation, there's no 2. Does that make sense? So for what they're explaining, they're talking about it within standard 2s to be within the 95%. It's going to be that. It'll be within 2. 95% of the time, it'll be within 2 standard deviations.
Okay.
So it depends on. Yeah, I don't know. That's all I know. So putting it all together, that's why it's got the 2 in there.
Okay.
So as you go down to formula, the actual formula for 95% confidence interval under 4.1 with a little more precision. It says the actual formula for a 95% confidence interval for the population when the standard deviation is known is this. Is the x bar minus and x bar plus the 196, all that stuff. And you get that 1.96 from the applet.
Mm-hmm.
Right. Okay.
Yeah, so that's the one that I have copied down because I looked at that and I'm like, okay, it's 2 deviations, but what if you're not doing 2 deviations? So I didn't even bother to write that note down.
Okay.
So yeah, this one just says more specific. This is what you're going to use. So that's how that comes into play. So that's how that works. Anything else, guys?
I'm okay.
Okay. So yeah, and then in the part 1, they just had us go ahead and punch it in so that we could get the numbers that they've been giving us for the 90%, 95, and 99, just so that we could see how they come out, how they found that, and we could see the change, how the z-score increases, or as the area under the curve increases.
I lost you guys. Where are you?
Number 5. Okay. Number 6 is the same as number 4. You good, Steph?
Yeah, sorry.
No problem. All right, so let's go ahead and go through. Is there anything you guys understand how to do the problems? It's just the formula. It's just you just punch in the details. You have to find the z-score, but the z-score is found by punching in the 95% confidence, which is So you just highlight the middle section on the applet, punch in your area on the top, and then whatever the z-score is, that is what goes in where the critical value is.
Okay.
And so it's just plus or minus that. So really what it is you're just using both the right and the left, but you're just in plus or minus because it's in positive or negative. You go to either side of the x-value. So, you guys follow? You guys need to go over anything? Are you guys ready to do
Yeah,
the
I just forgot to
We're
pull up
ready
my.
for the quiz. I'm ready.
I'm ready.
quiz? Are you ready to do the quiz, or do you need a little bit more?
I'm just pulling up the normal probability applet. I forgot to pull that up.
Oh, yeah. Luckily, I've used it so much, it comes up as
Yeah.
it's one of my options when I open a new window.
Probably would be for me too, but okay.
All right. Okay. All right. So it says, find the margin of error for 90% confidence intervals, and the standard of deviation is 50 and n is 25. So I forgot the formula for confidence interval.
You forgot what?
For the margin of error.
I asked Brother Williams a question. I'm trying to figure out the and I'm not
You
finding.
guys remember the formula for margin of error?
Yes, it's M. Wait. Never mind.
Well, I know it's the M, but I can't remember. So
And then it's the.
Well, I was.
Huh?
Sorry. Go ahead. Sorry.
Oh no, you're good. Now I'm trying to find it.
I wrote it down, but I can't find it in my notes.
The margin of error is m equals 2 times standard deviation over n. Is that right?
Yeah, so when we know the z-score, it would be like the z-score times the standard deviation over n.
That's when you're doing two standard deviations.
Oh, so we know the standard deviation is, so we know it's 90, so it's going to be 1.645.
Yep.
Oh, so it's just that part to the right. It's what you're plussing and minusing. It's the z-score times the standard deviation divided by the square root of the sample size. That's what it is.
Yeah.
Yep.
So this is the formula I was asking before what it meant. So it's the margin of error.
Margin of error. Sorry.
Okay.
Okay, so for 90%, it is 1.65. So 1.65 times 50.
1.645, right?
Yeah, so isn't it?
Yeah.
Was it 1.645?
Yeah.
You can
All right.
round it up to 5, but I think they want it 3.
Okay. Well, I was just going off of what they had us writing in the thing. From the notes, you know. I've stolen my daughter's graphing calculator. She keeps getting mad because she can't find it. Mom, where's my calculator with my stuff?
Okay, last night I was actually loving statistics. I was feeling pretty good about everything, and today I'm back to not really loving it as much.
Because this is so confusing.
Well,
I am confused.
thank you. I'm glad I'm not the only one. So right now, so you guys did the area of 90%. So you did that. You highlight only the middle section, or are you just doing 90% to get the z-score, and then you're solving for z? Is that what you guys are doing right now?
No, we're
Because-
solving N.
Sorry.
What?
Sorry. Go ahead, Brianna.
We type the, we get the z-score by typing 0.9 into the normal probability applet, and then we plug that into the equation.
Okay, and the equation is the z-score, the z equals 1, or which
The M.
equation?
It's M equals Z times the standard deviation divided by the square root of N. Of the
I should
sample.
z, not 2.
It's Z. Because that's the more, it says in the note, or it says in the chapter, it says what does it say? When you're, to be a little more precise, you just do it, you don't do 2 deviations, you just do 1.
Oh, okay.
Because it says the actual formula for a 95% confidence interval for mu when something is known is, and it's that sample, but it doesn't have the 2. It says no. Number 2 was used as an approximation for the actual value of 1.96. When computing a 95% confidence interval for a mean with a standard deviation known, please use 1.96 in the equation.
For Z.
For Z.
Mm-hmm.
Don't worry about the 2. That was just explaining how they get there, but you don't need the 2 because they want you to use just the standard deviation or just the Z-score from a 95 percentile.
So if you plugged the 90 percentile into your applet, it would give you the 1.645.
That's for
but that's for 90%. But are we on number 3? Are we doing the group meeting right now?
Mm-hmm.
So for that question, it's a 90%, which ends up with a 1.645.
Yeah. So tell me the equation again. Sorry.
So it's M equals,
M or N? M, right?
as in monkey, margin of error.
Okay. Margin of error. Okay. M equals.
Is Z, it's Z times the standard deviation divided by the square root of the sample size.
Okay.
When you plug that in, it's 1.645 times 50 divided by the square root of 25, which I got 16.54.
So,
Is that what you got?
yeah, I got like 16.45. So.
Yeah, that's what I got. Like, did I reverse my numbers? Yeah, I got 16.45 too.
Well, let me see if I got 2.45 instead of 16.4. Oh, you know what? I probably will get 4.5 because I punched it in as 5.4 in the first place. I just got a little dyslexic for a minute. So 16.45.
That's what I got.
Okay. All right. Which of the following statements is true?
I'm trying to read this and I don't know.
Okay. As far as a point estimator of the population of the meal. That's what it said in the notes. Yeah, because the X bar is the point estimator. And when they gave the formula for the confidence interval.
So X is a point estimator of the mean. The X bar estimates the mean.
X estimates the population mean.
Okay.
Okay, who wants to do next?
I'll do that.
Good job on your ecology tests.
Gina. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample size of 64 and computes X bar equals 526. Use this information for questions 5 through 8. So, what is the lower limit of this confidence interval? So first we need to find, well, that would be, you have to first find the z-score, right?
Mm-hmm.
Mm-hmm.
And then plug that into the m equals z times the standard deviation divided by the square root of the sample size.
So we got to
No, you're going to do the formula X bar minus the Z score.
So it's the same formula, but then you just add or subtract it to the mean.
Yeah. So first we have to find the z-score. Oh, it says 95%. For some reason I didn't see that. So it's a 95%. 95% they said is 1.96. And if you put it in the applet, that's what you get is 1.90.
Yeah.
So,
Okay, that's right.
Thanks,
So-
guys.
526. And I guess we'll subtract it, right? Because that's
We're going to be adding and subtracting.
We'll have to do both and see, and then whatever the lower limit is.
Yeah.
Okay, so we both add and subtract 1.96.
So for the lower limit, 498.315.
Yep.
Wait, what?
If your board isn't completely
What
plain
did you
before you do your toe edge, you catch your toe edge, and then it changes it blind.
Conversation, it's awesome. The lower limit, I got 526.
526 is
I forgot to subtract it farther. Sorry, I didn't realize what I just did.
Okay. I was like 526 is our X bar.
No, I just forgot to subtract it farther.
Okay.
That's all.
Brianna, how are you doing the math, the problem solving? Do you have a calculator on your computer and you're just typing all the numbers in as you do it?
No, I just have my little.
Oh, you have a fancy calculator. Yes. I should steal my kids', but she has statistics now too, and she will not be happy.
I can't remember. This one's from high school, but I don't think these are too expensive.
Yeah.
I got this bad boy. It was at Walmart for $89, and it graphs in color.
Wow.
I figured she's got 4 years of math, and well, she probably doesn't have 4 years because she's only going to do the 2 that she absolutely has to do. She hates math. I'm like, I love math. Math is my favorite. And they look at me like I'm insane. So 498.315. Is that what you guys got?
Yeah.
All right, sweet.
498. Wait, how did you get that? Can you back up?
Yeah. Okay, so you need to solve. You need to plug that into the formula for that's the x bar plus or minus z-score times the standard deviation divided by the square root of the sample size. So
Okay,
what you're
I did that. Did you get 27.685?
27.685. Yeah. So now you'll add that to 526 and subtract it from 526.
Okay. I just didn't do one more step. Okay, sorry.
No problem.
Good.
You add it and subtract it. So when you add and subtract it, then you'll get both answers.
And then what do you do with both answers once you get them?
Well, number 5, it wants to know the lower limit, so it's going to be the lower one, which is 498.
Oh, okay. I'm like, what I was confused about is what do I do with these two numbers? I didn't read it.
Well, that's what it's asking us for, is for the upper and lower limits. So the lower limit.
So for the upper limit, did you get 553.685?
Yes.
Yeah. That's what I got.
Okay.
And you guys are putting 3 decimal points, right? So
Yes.
3.685. And then did you get 498.315?
Yes, that's what I got.
Okay.
Yeah.
I'm with you now, kind of.
Okay. What, 498.315? Is that what you said? All right, cool.
498.315.
Mm-hmm.
Okay.
All right, and then for number 7, what would happen to the width of the confidence interval if you increase the sample size? You increase the sample size, the confidence interval, the margin of error decreases.
Yeah.
Would decrease. Decrease?
Yeah.
Okay.
Then on number 8, the confidence interval is raised to 99%, there would decrease.
Increases.
You guys said decrease on both?
Oh.
Hold on.
And
I had a note that said, hold on.
you Allison has a hospital in your
What class do you have next, Brianna?
Ecology.
Ecology?
Yeah.
So increasing the confidence level will lead to a larger values of Z. If Z is increased, then the margin of error would increase. This would lead to a wider confidence interval.
Says if the level of confidence increases with the confidence level
So it would increase, right?
increases.
So it increases?
Increases because it said if you're well, if you think about it, the higher you're going to be more confident because you widened it out. You know it's got to be here. You're no longer looking at a smaller area. You're saying it's going to give you a bigger area to be sure that it's going to be in that area.
Yeah, that makes sense. But
But if I say 6 and if I say it's between 5 and or 3 and 12, I know it's going to be in there. I'm pretty sure it's here, but I know it's going to be in there. So your higher confidence level, you have a bigger area. Does that make sense?
yeah, makes sense. But did you guys you're both reading from something. Did you read that from chapter 10 really fast?
No, that was the notes that I took from the PowerPoint.
And mine was in 4.2, the answer, because it says what would happen to the confidence interval if the confidence level were increased, say from 95 to 99%. That was a question.
Oh, okay.
And then the answer is that it would lead to larger Z value. If Z is increased, the margin of error would increase. This would lead to a wider confidence interval. Okay.
Okay, let's keep going because we've got like 4 more problems. 1, 2, 3
Okay.
problems, and Brianna's got to go to class in like 8
Okay.
minutes.
Bright Bulb Light Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
Okay, that's where we use this formula right here.
Okay, don't leave it up there for a second.
I will. I just got to get it up there.
Keep talking.
That's where we use this formula. So we just plug everything in. It's a plug and chug. It gives you all those values, doesn't it?
What does this say? Z times what? Divided by what?
Theta. That's the standard deviation.
Sorry, it got blurry. Sorry.
Problem.
Can you put it up again to the camera?
I can't see what I'm.
Oh, there we go. That was like a 5. I'm like, that doesn't make sense. That's not a formula. Okay, so n equals z times standard deviation divided by m.
And now squared.
Square. Okay.
So that gives us with 95 is 1.96, right?
Yes.
Okay,
Okay.
times 400 divided by 50.
And then you always round up.
After you square it. So it's 2.458. Well,
So 246?
Yeah, 246 is what I got.
I don't know why I just got. What the heck?
Well, just because I think you got the right answer, you just round up.
Oh, because I divided by 500 instead of 50. Apparently I hit. This doesn't make sense.
Oh, I did 52. Oh, you're supposed to do 50. Okay. I'm like, oh no, I did it wrong.
No, I just, yeah.
And then once you figure out that number, then what do you do with it?
That's
how many people you need
I'm
to
not
survey
So you need 246.
or sample. That's the sample size that you need for
Yeah.
this test.
Okay.
Well, wouldn't you do So you do 196 times 400 divided by 50, right?
1.96 times 400 divided by 50, and then that whole thing, that once you get that answer, you square it.
And yeah, and that's 15.68. That's what I got, right?
Square that. Square the 15.68.
And then, but I got 3.9597.
No, don't square root it. Square it.
I'll square it. I'm like, that is not a big sample size for 4 people. Okay.
I know, that's what happened to me. I'm like, why do I have like 3? That doesn't make sense.
Okay, because I was used to doing the square root of stuff, so. Okay, 15.68. No.
All right. Oh, I hate these ones sometimes. All right, sample size 36. Okay, who wants to do this one?
Okay, wait, did you guys get 245.862?
245.86. So, yeah, it's 245, so you round up, so it gives you 246.
Oh, yeah, that's right.
So on number 10, I'm kind of confused about what we do with the 100,000 and then the 111,000.
For this one, the population is 100,000 with a standard deviation of 36,730. So the hypothesis test, it's set up with the frequency of 0.05.
No, I didn't.
Okay, so this is where we have to find the z-score, like where we subtract the.
Find the z-score first for this. Actually, what it's doing is we're finding the lower limit and the upper limit.
And then shade in between it.
Yeah, we just have to do the lower limit. This one's a lot more detailed, but yeah, what we're going to be doing is we're looking for a confidence interval, so we're not actually solving for the score. We're looking at the bounds of this. We're looking for the limit of this.
Okay, seen those guys? They really.
Why is this different than questions 5 and 6? Because it has the A.
But yeah, but we don't know what the score is on this. Hold on, so right, we don't have this.
I'm like totally lost on this one.
All right, let's see if my brain will go here. All right, so the z-score you get from the 95% confidence.
Well, 95% is at 1.96.
So it's 111,000 plus or minus 1.96.
How are you?
36,730 plus 5 square root 36. Right? Is that making sense? Does that sound right to anybody?
You're kind of cutting out a little bit. Patty, I didn't hear everything. Can you say it again?
Okay, so I have 111,000 plus or minus 1.96 times 36,730 divided by the square root of 36. Does that look right?
Yep.
Does that sound right? Am I crazy?
Well, what formula are you using?
That is the confidence interval. The x bar plus or minus.
Man, you told me you
Okay.
I guess I'm just confused because we have all this other information
Are we having class or what?
that we're not using.
The level of significance. Here's the thing. If I remember right, it said the level of significance. Oh, where was that in my notes?
So I'm saving this for later, and I'll probably just come back and finish it after.
Here you go. The last number 12 is the requirements. Simple random sample. Normally distributed. Theta is known, so it's all of the above. And in this one, you just solve for the upper and lower limits using that
one formula with the plus this. Oh, I see what you're doing.
So the x bar plus or minus the z-score time, or the critical value. So the z times the standard deviation divided by the square root of the sample size.
I don't know what's happening right now.
And the level of confidence and the level of add together equal 1. So basically, it tells us the level of significance is 0.05, and then it tells us it wants the 95 percentile confidence level. They're actually asking for the exact same thing. They just do something in it that lets you go, huh? So it gives you 2 different ways to solve it. So to compare it, you're not actually comparing to that. Does that make sense?
Kinda.
I just saved mine, so I'll probably finish it after my class.
Go for it. But now you
Okay.
know what we're doing, so when you look back, you'll see where we are.
Yes.
We're just going to finish out the math on that.
Okay, thank you so much.
You're welcome. We'll text you because I might have to change the appointments for Tuesday and Friday next week. So I'll you guys and let you know like that. I'll talk to them and then we'll text you.
Thanks.
Thanks.
Bye.
Thanks. See ya.
See you later.
Yeah, we'll talk about that after we're done. But I have stuff next week that I forgot about.
Okay.
Okay. So, 1, 6. It helps if you don't put decimals in. When you don't need decimals. Just saying, you know.
For the lower limit, did you guys get 104,878?
Hold on, I am not done yet.
No, I didn't.
Dang it. I just want to know if I'm
I
right.
don't know. I better check my work again.
Well, then before you check your work, let's see if we're typing in the same stuff. So for the lower limit, you know, plus or minus, so I'm going to use minus. I did 111,000 minus 1.96 times 36,730, and you divide the 36,730 divided by the square root of 36, which is the sample size, and I got 104,878.
Okay. Well, yeah, I better recheck because I got a higher number for my lower limit.
But is that how you did your formula? Are those the numbers you did?
The 111,000 minus 1.96 times 36,730 over the square root of 36.
Yep, that's what I did too.
Okay. So somewhere I did my math wrong.
Yeah, because my answer for just that second part is higher than the 111,000. Oh, no, it's not. I just put my comma in the wrong place again. Oh, gosh, where was my brain? See, commas and periods do not mix well with me.
That makes it hard, especially when you get these big numbers and you actually use a comma. We haven't been using commas yet.
Mm-hmm.
Oh gosh, I don't know what I'm.
We're dealing with dollars, isn't it? Dollars that we're dealing with. So yeah, so you only have to go. We only have to round to the second, to 100, because we don't have partial pennies.
Did you guys do the upper limit yet?
I got 122,998.47.
Yeah, but it says we're under the nearest whole number. I didn't realize that. So 122,998.
Yeah.
Do we need to do commas when we type in the answer on the?
I don't know if it'll let you.
Oh, good point. It doesn't let you. So
That's how I found out half the stuff.
tried it and it won't let you.
Oh, well, let me do that. For the lower limit, I got 99,002.
I got 104,878.
Well, maybe my math.
I got 99,002.
Well, oops.
All right. Well, I'll do it one more time and we'll see where we're at. Although we got 2 of us getting that one, so here's hoping. Yeah, I got 99,002.
There it is. I don't know what I did wrong. 99,002. Is that what you said?
Yes.
Okay. What did I do wrong?
I don't know. Could have been like me, where you hit 500 instead of 50.
Oh, I forgot to times it times 1.96.
Well,
I
there
did the formula, but I forgot the Z4 part.
What I'm doing is I do that part that's in parentheses first, and then I write that down, and then I just add it and subtract it.
Okay, so the lower number is 99,002.
Yep.
And then the upper number is 122,998.
Yes.
Yep.
Okay. It took me about 5 times.
That's good. That's not bad. That's good.
Well, I didn't mind once I realized that I was actually had the comma in the wrong place, and that's why I was trying to figure out what the heck happened.
Oh.
Well, I had 11,998, and I'm like, how did I get 119,000? That doesn't make sense. I
I would get more.
haven't figured out our limit yet.
Ah.
I'm like, I haven't added or subtracted. It means that's weird. So,
That's the thing about numbers. You mess up one tiny thing and the whole thing's messed up. Like you can't come back and fix it later. You know, you got to get every little thing
seriously.
on. You know. Okay, so 12. I know you said it's all the above, but I didn't actually read it.
Okay.
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are a simple random sample was drawn from the population. X bar is normally distributed. Standard deviation is known.
Yep.
Confidence interval for a mean. You need all of that information.
Yeah, it says requirements in the lecture. It says the requirements for confidence interval for one sample. You need a a simple random sample. You need to know the standard deviation, and you have to have normal distribution, either because the population is normally distributed or because your sample size is high. So for the central limit theorem.
Okay.
But either way, your sample needs to be normally distributed.
Okay. That
Okay.
makes sense. All right. You guys ready to do this?
You guys ready to submit?
I'm ready.
All right. Let's do it and find out. Hey, woohoo!
Yay!
All right.
Okay.
I didn't miss one.
Recording, and then we can chat a little bit about the next couple stuff.
Okay.